Here's how to do transformations, reflections, and rotations on a graph. So first let's go over how to do a translation. That's basically where you take a shape on a graph and you move it up, down, left, or right. So we have 3 points here that we're going to need to plot on our graph, and then those are going to make a triangle because triangles have 3 points. And then we need to perform this translation. So we're turning x, y into x plus 1 and y minus 2. Or another way that your translation problems might be worded is it might put it in vector form. So the problem might look like this. It'll have like these vector symbols, and then it'll say 1 minus 2. So if you see something like this just means the same thing as this. We're adding 1 to x and subtracting 2 from y. So we need to start by plotting the points of our triangle. So let's start with point A. Point A is 3, 2, and it always goes x first and then y. So x is 3, and x is left and right, and positive numbers are to the right. So we need to go 3 squares to the right. And then our y value is 2. Y is up and down, and positive numbers go up. So in addition to going 3 squares to the right, we also need to go 2 squares up. And this is going to be the final location of point A, and we'll label it A. Next is point B, which is negative 1, 1. So negative 1 for x, that means we need to go 1 square to the left, and then positive 1 for y, so we need to go 1 square up. And this will be point B. And finally, we have point C, which is 2, negative 2. So 2 for x, remember x is left and right, and it's positive, so we need to go 2 squares to the right. And then negative 2 for y, so y is up and down, negative numbers go down. So we need to also go 2 squares down, and this will be point C. So once you've plotted all of your points, you just need to connect all of the points up with lines to make your shape. So now we just need to perform this translation. And basically, we're just going to be adding or subtracting from x and y on every point. So you could just add them directly to the numbers on the points and then plot those points. I'll do it the opposite direction. I'm going to show you how to do it on the graph first. And then if you want, you can figure out the coordinates of those points too. So x plus 1, we're adding 1 to x. And remember that x is left and right, and positive numbers go to the right. So if we're adding 1 to x, we're moving everything to the right 1 square. So point A is going to move to the right 1 square, point B is going to move to the right 1 square, and point C is going to move to the right 1 square. But I'm not going to plot those points yet because we also have to do this second translation of y. So y is being subtracted by 2. We're subtracting 2 from y is up and down, and as y goes down, the points go down. So by subtracting 2 from y, we are moving all of the points down 2 squares. So point A is going to move down 2, point B is going to move down 2, and point C is going to move down 2. So I'm going to plot new points in all of these new locations. And we can also name these points. So whenever you do a translation or any sort of other thing, then the new versions of those points are going to be called A prime, B prime, and C prime. That's what the little apostrophe means. It means prime. And now we can just connect these up with lines, just like before. And you'll notice that when we do that, the shape looks exactly the same. It's the same exact triangle. We just moved it down a little bit and a little bit to the right. So a translation always keeps the same shape. It doesn't change its size or anything. It just moves. And if the problem also asks you to figure out the coordinates of these new points, then you would just count the boxes. So I'll show you point A prime, for example. From the middle of the graph, we have to go 4 squares to the right to get to A prime, which means that A prime, the x value of that is going to be 4. But the y value, we actually don't have to move up or down at all. So y is going to be 0. So A prime is going to be 4, 0. For B prime, we don't have to move left or right at all. So x is going to be 0. And we have to move 1 square downward. So y is going to be negative 1. And then for C prime, we have to move 3 squares to the right. So x is going to be 3. And then we have to move 4 squares downward. So y is going to be negative 4. So there you go. That's how you do a translation. Now, what about a reflection? How do we perform a reflection on a graph? Well, it says that we need to reflect across the x-axis. The x-axis is just the big left and right line that you see on the graph. You see it's labeled with x. this one up and down here is called the y-axis. So just so that we don't forget, I'm going to draw a little line right here on the x-axis. And basically our goal is to take whatever shape we end up with, like let's say we had a triangle here, then we would use this x-axis as a mirror. So the new shape would be like this. It'll be a mirror image. So we first need to start by plotting these 4 points and drawing our shape. So I'll show you the first point as an example again, but the rest of them you can do on your own if you want. So point A, we have -1 for x and 3 for y. So -1 for x is left and right, and negative numbers go to the left. So we need to go 1 square to the left. And then 3 for y is up and down, and positive numbers go up. So we need to go 3 squares upward. And our final point is going to be right here, and we're going to label it point A. So I'm going to go ahead and plot the other points now. Feel free to pause the video and try it yourself, and then you can come back and check your work. So here are our 4 points, and now we're going to connect them up, and it looks like it's going to make some sort of weird like parallelogram maybe. So now we have our graph, and we need to reflect it across the x-axis. And we're going to do this with each individual point. So looking at point A first, we are going to flip it as a mirror image across the x-axis. So right now, point A is 3 squares above the x-axis. So to reflect it, we need to now have it 3 squares below the x-axis. So this is going to be our new point A, and we're going to call this A prime. Now notice how point A prime is not anywhere different on the left and right scale compared to point A. So when we're reflecting across the x-axis, then its x is actually not going to change, only its y is going to change. Let's look at point B. Point B is 4 squares above the x-axis, as you can see here, 4 squares. So we now need it to be 4 squares below the x-axis, and this will be point B prime. Next is point C. Now, we need to reflect this across our mirror, our x-axis, but it's actually already on that line. It's not above or below it. So point C is actually going to stay right where it is. We don't need to move it at all. Now, point D is actually on our other side of the mirror. It's below the x-axis. It's 1 square below. So we need to now move it 1 square above. We're just reflecting it the other direction. So now that we have our 4 points, let's go ahead and connect them up. So here we go. We have our new mirror image, our new reflection. Now, unlike the last time where the translation just moved it around, but it didn't actually change the shape, this one does change the shape. It like flips it around. It's the mirror image. And I know that it's a little weird because the shape is going through the mirror. That's not really normal. But yeah, you can still reflect it even if it's going through the x-axis. And if it's said to reflect across the y-axis, then you would basically just treat this up and down line as a mirror, and then you would mirror them like this direction. So now let's go over how to do a rotation of a graph. So we have 3 points here, and we need to rotate these points 90 degrees about the origin. So let's say we had a triangle like this, for example, and we need to rotate it 90 degrees. So the origin is basically the center of the graph, like this. So when we're saying we're rotating it around the center of the graph, like this. Now, technically, there's 2 ways you can rotate this. You can rotate it counterclockwise, or you can rotate it clockwise. Usually, our standard is that counterclockwise is the positive direction, and then clockwise is the negative direction. So if it says to rotate it 90 degrees, then you can assume it's saying counterclockwise, like this direction. But if it said rotate negative 90 degrees, then that would be the other direction. It would be clockwise. And remember that a full circle is 360 degrees. So 90 degrees would be a quarter of the way. So it would be like we rotate this way, and then our new triangle would be like this. And then 180 would be down here, 270 would be over here, and then 360 would be just a full circle. So I'm going to go ahead and plot these 3 points. Feel free to pause the video and follow along, or try to do it yourself and then see how you did. So here are 3 points, and it says that we need to rotate it 90 degrees, so like this way, and we're going to have some sort of shape here. Now there's 2 different ways to do this. There's the way that you were probably taught how to do it, which is a little bit harder depending on how you're doing it. And then there's a second way that I think is easier to understand, but you probably weren't taught it that way. And it might be a little harder if you're doing this like digitally compared to on paper. So first, let me show you how to do it the way you were probably taught. So there are 3 different rules for rotations. If it's a 90-degree rotation, then your coordinates, like we're just going to use A, B as an example of coordinates, then those coordinates are going to turn into negative B, A. So basically all this is saying is you need to flip the 2 numbers around. So these need to switch. And then you need to make the first number, the new first number, negative. This is the one that we'll be using because it's a 90-degree rotation, but I'll go ahead and write down the other rules in case you need to use them too. So if it's a 180-degree rotation, you don't need to swap them, but you just need to make both of them negative. And if it's a 270-degree rotation, then you do need to swap them, but instead of making B negative, you're going to make A negative. So here's the list of the 3 different rules. You can take a screenshot of this if you want, but I'm going to erase these bottom 2, and I'm just going to look at 90 degrees because that's what we'll be using. So first, let's find out what A prime is going to be. We're going to take A, which is 1, 4, and we're going to start by swapping them because instead of AB, we have BA. So instead of 1, 4, we're going to have 4, 1. And then it also says that we need to make B negative. Remember, B is over here now. B is 4. So the first number is going to become negative. So our point for A prime is negative 4, 1. And then we'll go ahead and plot that on our graph. So negative 4 for x, that means we need to go 1, 2, 3, 4 squares to the left. And then positive 1 for y. That means we need to go 1 square up. And this will be A prime. Now that was kind of a lot of work. I'll show you how to do that for the other letters. And then remember, there's going to be an easier way that I'll show you in a second. Now B prime, we had 3, 4. So remember, we have to swap them because it's BA now instead of AB. And B is now going to become negative. So we'll put a negative sign on 4. So again, we need to move 4 squares to the left, and then we need to move 3 squares up, which I'm now realizing my stuff is in the way. So I'm going to move this down. So this is where point B prime is going to be. And now let's go ahead and do the same thing with C. So C prime is going to be, instead of 3, 1, it's going to be 1, 3, because we have to swap them. And B is now negative, so it's going to be negative 1, 3. So that's 1 square to the left and 3 squares upward. And now we just need to connect these points up with a triangle. And there you go. This is our new rotated version. So it looks like we just took this triangle and rotated it 90 degrees around the middle of the graph. Now I'm actually going to erase this because let me show you the easier way to do this. And this is going to be easier if you're doing this on paper. If you're doing this on paper, you have an advantage because you can literally just rotate your paper 90 degrees. So I can't really do this on here, but I'm just going to, I guess with the magic of editing, this graph is now just going to like rotate 90 degrees. I'm like, cool. I hope it did it. So now you're probably looking at some incredible editing and I can't really draw stuff anymore. So I'm just going to say what you're doing. So where point A is now on your rotated piece of paper, I want you to figure out what the coordinates of that are. So looking at point A, you'll see that you need to go 4 squares to the left and then 1 square up. So A prime is going to be exactly where point A is right now when you rotate your paper. So point A is 4 squares to the left, that's negative 4 for x, and then 1 square up, so that's positive 1 for y. And once you've done that for all 3 points, you can now rotate your paper back and then just go ahead and plot those points that you figured out on your graph. And if you do that, then you should end up with all the same points that we had before, like this. So there you go. This is the rotated version of the original triangle. So now you know how to do translations, reflections, and rotations of a graph. But there's actually one more important one that I didn't talk about in this video, and that is dilations. So if you want to learn how to do that, then you can watch this video right here. And as always, if you have any questions about this video, go ahead and leave it in the comments and I'll be sure to answer your question. Thanks for watching.